Students, today we will be solving few important questions on circle based on the theorem angle in segment, same segment, angle in semicircle, and angle subtended by an arc at the center is twice the angle subtended by the same arc on the remaining part of the circle. So let's begin with this. First question, if O is the center of the circles given over here, find the value of x in each of the following figures. So let's begin with the first part. So in the first figure, as you see, AB is the diameter. AB is the diameter. So I can say angle ACB is 90 degree. Angle in semicircle. Okay. Now these angles become 90. In triangle ACD, using angle sum property, I can say that angle A plus angle ACD plus angle ADC is 180 degrees, angle sum property. So ACD will become 180 minus 50 plus 90, which is 140. So it will change to 40 degrees is ACD. Okay. So ACD becomes 40. So you know 40 plus x is 90, right? Which we used here. ACB is 90 degree. So x is equals to 50 degree. I hope it's clear, students, right? Now, in the second part, here in the second part, what do you observe? That AOC and COB, what do they make? AOC plus COB, they make a linear pair. So they both add up to 180. So I can say COB will be 180 minus 130, 50 degrees, right? So this becomes 50. Now, COB is twice of CDB. COB twice of CDB, angle subtended by CB at the center, angle subtended by CB on remaining part of the circle. So we can say CDB is 50 by 2, which is 25 degrees. Clear, students? This I'll write CDB. Okay, now the third one. CB is the arc or chord, you can say here. So this chord is making angle 40 degree here. The same chord is making angle this here. So I can say that these two angles are equal. Reason being CAB equals CDB, angles in same segment. Okay, students? So here I have not written the reason for the bigger one because this is a 1 mark kind of question. So you can consider it later on when it's a 2 or 3 marker, we will write it down. Yeah. So I can say that now CDB is how much? 40 degree. Now, what do I have to find out? I have to find out x here, right? So it's a triangle CDB. So angle sum property. So in triangle CDB, we have two angles. Angle CDB plus angle CBD plus angle DCB, 180 degree, angle sum property. So let's write CDB 40, CBD we have 80, and this is x. So x is 180 minus 120, so x comes out to be 60 degree here. Clear, students? I hope it's clear, all the three parts. Now move to the fourth and fifth part of this question. So fourth part says that this angle is 50. One of the angle is 50. So I can say that angle OAB equals to OBA. Can I say both are equals to 50, students? Reason being OA equals to OB, and that becomes an isosceles triangle. Okay, so now you can either say AOC directly. So can I say AOC equals to OAB plus OBC? Exterior angle property here. Fine, I'm using exterior angle property of a triangle, which is equals to sum of interior opposite angles. So AOC will become 50 plus 50, 100 degrees. Okay, you could have also used angle sum property, getting it 80 and then using linear pair. So I eliminated those two steps and got it in one step only. Now again, this AOC is twice of ADC. Same reason, arc AC. This arc is making an angle 100 degrees at the center. Same arc is making half of 100 at D point on the circle. Okay. So what will be half of AC? So it will be 100 by 2. That's ADC, which will be equals to 50 degrees. So I hope that is also clear, students. Now move to the fifth part. Now in the fifth part, same thing we will be using. So in triangle AOB, OB equals to OA radii. The reason for that is they both are radius. So again, it's an isosceles triangle here also. Yes, students. So 40 plus x as these two angles will be same, right? That's 180 degree. Angle sum property के साथ we will be solving it. So I'll get 2x is equals to 140. So x comes out to be 70 degrees. So this part is also done, students. I hope it's clear. Yeah. Now let's move on to the second question. In the given figure, AB is the diameter of the circle with center O. AC and BD produced meet at E and angle COD is 40 degree. Calculate CED. So this is what we need to calculate. Now AB is the diameter. So let's write AB is the diameter. So can I say angle ACB? This angle. Angle ACB 90 degree. Reason angle in semicircle. So BCE also, BCE plus ACB both are 180. That's a linear pair, right? So I can say BCE is also 180 minus 90 degrees. We have this also as 90 degree. Now where do we proceed? How do we solve it? If you see, CD is an arc. So COD. So angle subtended by arc CD at center O. So basically enters angle COD is 40 degree, right? Yeah, this angle is twice the angle subtended by CD on the circle, right? Yeah, so where is that? So CD is also making this angle CBD, right? So COD is 40, so COD is twice of CBD, so CBD will be half of that, right? So what will I get? 20 degree is CBD. So we got CBD as 20 degree. Now we have this triangle, and in this triangle we have everything. In triangle CBE, you have BCE, you have CBD, and CED we have to calculate. So using angle sum property we are done, students. So angle CED is what? 180 minus 20 plus 90, which is 110. So that comes out to be 70 degree. Let's cross check if there is a mistake in calculation anywhere. 90 is right here, right? 90 using angle sum property, linear pair. Then using the theorem, COD is double of CBD. We got it 20. Then 20 plus 90 is 110. 180 minus 110, 70. We are done. Clear. Now move to the third question. In this given figure, again we have given that PQ is the diameter, right, of the circle with center O. PQR is 65 degrees. SPR is given to us as 40 degrees. Let's make a figure little bigger, this figure. Now we need to find out QPR. Q, this angle first, okay. Then QPM, this angle also we need to calculate, okay. And then PR is this angle also we have to calculate, okay. Fine. So let's begin with the problem, students. So PQ is the diameter. As we have diameter, let's see angle in semicircle. So we have one here angle in semicircle, one here, right? So you can say angle PRQ is 90 degree, angle PMQ is 90 degree. Both the reasons angle in semicircle. Now we have two triangles. In triangle PRQ, So angle RPQ we do not have, we have to find that out, plus PRQ plus angle PQR 180 degrees, angle sum property. So from here we can say RPQ, or I'll say QPR, 180 minus 90 plus 65. Okay, so what's that? 5, 9 and 6 is 15. So when you subtract, 25 degrees. Yeah, so this comes out to be 25 degree, 90, 25. Same way, in triangle PMQ, you have angle QPM plus angle PMQ plus angle PQM, 180, and angle sum property. Using the same thing, we will be calculating angle P, not angle, I'll write it fully, angle QPM, which you have to calculate, is 180 minus 90 plus 50, right? So that's 140, so it's 40 degrees. Okay, so this is 40. Clear, students? This is also done. So two angles we have already calculated. This is this, and this QPM is also 40, right? Now we need to find out PRS. Now PQRS, what do you know about PQRS? Is a cyclic quadrilateral. We will be using this also here. What do you mean by a cyclic quadrilateral? All the vertices of this quadrilateral PQRS, they are on the circle. Okay, so the property of a cyclic quadrilateral is its opposite angles are supplementary. Yeah, so angle S plus angle Q is 180 degree, right? They are opposite angles of a cyclic quadrilateral. I'm writing it in short here. So I'll get angle S equals to 180 minus 65. How much is that? 7 minus 6 is 1. 115. Okay. So these angles come out to be 115 degree. Now again angle sum property in triangle SPR. Angle S plus angle SPR plus angle SRP is 180 degrees, angle sum property. So SRP we have to find out, 180 minus 40 plus 115. So how much is that? 551. So when you subtract it, you get it as 7 minus 5, 2. This is also 25 degrees. Yeah. So this also comes out to be 25 degrees. Okay, students. So I hope this is clear. We are done with the question. Yeah. So first two angles, these two, using 90 degrees angle in semicircle, you find out using angle sum property. Then again cyclic quadrilateral property, S and Q opposite angles of that, so add up to 180. So from that we get S, and then again using angle sum property I calculated this angle R. Okay. Now move to the last question of this video. Now in this figure given below, P, Q are the centers of the two circles intersecting at the points B and C, BC. ACD is a straight line. Find X. We need to find out this X. Okay, so let's begin with this. Now angle APB is equals to double of angle ACB. Angle subtended by arc AB at the center is twice the angle subtended by AB on the circle, right? That is what I'll write. So I'll get ACB equals to 150 by 2, which is 75 degrees. Now this comes out to be 70. If this is 75, what about this angle? Angle BCD. So ACB plus BCD is 180 degree linear pair. So BCD comes out to be 180 minus 75, 105 degrees. So this angle is 105. Okay. Now if I talk about BFD is a major arc here. What is it? It's a major arc, right? Okay. So what about this angle BQD? That is equals to twice of angle BCD. Same thing. This is double of that. Yeah. So 2 into 105. How much will be that become? 0, 1, 210 degrees, right? That's 210 degrees. So this comes out to be 210 degrees. Now what will be x? So x will be 360 means say we will subtract. So I'll just write 360 minus 210 degrees. So how much you will get? 0, 5, 150 degree. So this x comes out to be 150 degree over here. So I hope it's clear, students. We could have done it in another way. So if you people feel like, some students they prefer joining this, okay, right? So if this is 105, they'll make this as 75 because cyclic quadrilateral property, right? And then double of that will be again 150. Okay, so both the ways are correct only, so you can refer any of the ways, right, students? So I hope it is clear till here.